In section 3.1, we're going to remind you of a bunch of rules of probability that you've seen at some point in your life. The first part of it is called discrete random variables, and this part is largely a review of things that you've seen throughout your career. Probability is introduced really early on in school and kind of covered in various classes throughout the K through 12 education. And so the first part is reminding you of stuff you've seen before, some of the basic ideas of probability, and this notion of a discrete random variable, which even though you have maybe not used that terminology before, it's really what you might traditionally think of probability as. A classic example, which is what we start with, is if you roll two dice and add the two numbers together, you get what's known as a discrete random variable. The values it can take on are discrete, they're separated from each other, and each value has some probability of occurring. So that first part will be a good reminder of all this stuff. You might have to look some things up, but hopefully when you finish that part, you'll remember all of these things, or at least be on the way towards remembering those things. Part 2 is called continuous random variables, and I think for a lot of people this is going to be a new type of thing. So the idea of a continuous random variable is that we're talking about probability not in terms of the probability of a specific value occurring, but in terms of the probability of values occurring in some range. And so I want to give you two examples of this notion, in particular of this idea where we think of probability in terms of the area under a curve. So I'm going to give you two examples of a similar thing. And so example 1, in both cases, what I'm going to be doing is I'm going to randomly choose a number between 0 and 1. So in example 1, when I randomly choose a number between 0 and 1, so it could be 0, it could be 1, it could be a half, it could be the square root of 2 over 2, that's less than 1. It could be any real number between 0 and 1, but I'm going to do it what's known as uniformly. So it's going to follow the uniform distribution. And so in this example, the way I think about this is as my number is going to fall somewhere between 0 and 1. And the height of this is going to be 1. And I think of this as representing, this graph here is representing my probability. And what I mean by that is I'm going to choose some number between 0 and 1. And so the total area under this graph, the base length is 1 and the height is 1, so the total area is 1. So something will happen. I'll pick some number. And then if I wanted to know more specifically the probability of a number less than 0.5, what I would do is I would shade in the area between 0 and 0.5. And this area that I'm shading in blue represents this probability. So a number between 0 and 0.5. And this area is a half because this is a uniform distribution. It's a flat line. The base length is a half. The height is 1. And so the area of that rectangle is 1/2. Now let's make a slightly more interesting example where here in example 2, I'm still going to be picking numbers between 0 and 1. But as numbers get higher, they're going to be more likely to occur. And so I'm going to do something like this. We line up here, and this height is going to be 2. Now, why is the height 2? Because I've drawn a triangle here, and the total area, if this is going to represent a probability, has to be 1. That is, I'm going to pick something between 0 and 1. And so the area of a triangle is base times height divided by 2. And since my base length is 1, my height has to be 2 to make this total area 1. Now, again, I can ask, what's the probability of a number less than a half? And here it will be less likely than it was in the first case. So I'll draw in 0.5. And the height of this triangle that I'm about to shade in is going to be 1. And this total area Well, the area of a triangle is the base length times the height times a half, which is 0.25. So in this case, I guess you can't quite see it here on this screen. Let's zoom a little. In this case, the probability that I pick a number less than a half is 0.25. So in this course, we'll largely be talking about this in terms of what's known as normal distributions and other probability distributions like t-distributions and chi-square distributions. In this section, in section 3.1, we'll use more basic figures like the uniform distribution. I don't think we have an example quite like this, but these geometric figures are a nice place to start because you can actually do the calculations using geometry, whereas the general calculation of finding an area under a curve requires calculus. So this is the idea of 3.1. The first part of it is reminding you of things that you at some point have seen about probability, but likely forget some of. And the second part is introducing this concept that to a lot of you I think will be new, of probability of a value falling in some range in terms of areas under curves.